Look down at your hand right now. Really look at it. The calcium in your bones, the iron in your blood, the oxygen filling your lungs this very second. None of it was made on Earth. All of it was forged somewhere else, a long time ago, inside the furnace of a dying star. But the reality out there in the void is far more terrifying than a poetic metaphor. It is a story of violence, collapse, and explosion on a scale your mind was never built to hold. Start at the beginning. Not your beginning, the universe's beginning. Right after the Big Bang, there was almost nothing to work with. Just hydrogen, a little helium, a trace of lithium, that was it. The entire periodic table, all 90-something natural elements, did not exist yet. No carbon, no oxygen, no iron, no gold. The universe was staggeringly simple and staggeringly boring. So how did you get here? How did a universe made of two gases learn to build something as complicated as a human being? The answer is stars. Billions of them, one after another, quietly working as furnaces for over 13 billion years. Here is where it gets strange. Inside a star like the Sun, gravity is trying to crush everything inward. Nuclear fusion is pushing back outward. Hydrogen atoms slam into each other under unimaginable pressure and fuse into helium, releasing light and heat in the process. This is the tug-of-war that powers every star you have ever seen. For most of a star's life, this balance holds. Quiet, stable, boring even, if you were watching from a safe distance, but stars run out of fuel. And when the hydrogen runs low, things change fast. A star several times more massive than the Sun begins to fuse helium into carbon, then carbon into neon, then neon into oxygen, into silicon, and eventually into iron. Each stage burns faster and hotter than the last. What took millions of years in the hydrogen phase might take mere days by the time the star is fusing silicon into iron. The star is racing toward its own destruction and does not know it. Here is the part that should stop you cold. Iron is where the party ends. Fusing iron does not release energy. It absorbs it. The moment a massive star's core turns to iron, the furnace that has held gravity at bay for millions of years suddenly stops fighting back. And gravity wins. In less than a second, a core the size of the Earth collapses down to the size of a city. The outer layers of the star, still unaware that the support beneath them just vanished, come crashing inward at a significant fraction of the speed of light. They slam into the newly formed core and rebound in one of the most violent events the universe is capable of producing. A supernova. For a few weeks, a single exploding star can outshine an entire galaxy of 100 billion stars combined. Astronomer Fritz Zwicky first coined the term supernova in the 1930s, trying to describe something so bright it barely made sense. He was right to be stunned. In that explosion, temperatures spike into the billions of degrees. And in that chaos, something remarkable happens. Elements heavier than iron get forged in an instant. Gold, silver, uranium, platinum. Elements that no ordinary star could ever build get created and flung outward in a matter of seconds, scattered across the galaxy like debris from a cosmic collision. The astrophysicist Fred Hoyle spent much of his career trying to prove exactly how this worked, mapping out the chain of fusion reactions that build heavier elements from lighter ones inside stars. It became known as stellar nucleosynthesis. Hoyle predicted a very specific nuclear reaction had to exist for carbon to form in the abundance we observe, and years later, experiments confirmed he was right. Every carbon atom in your DNA exists because his math worked out. So, the calcium in your bones. That came from a star that lived and died before our sun was even born. The iron in your blood, the very molecule your red blood cells use to carry oxygen right now, was forged in the final seconds of a star's collapse. The oxygen you just breathed in was cooked inside a stellar core over millions of years, and then blasted across space in an explosion visible from other galaxies. Carl Sagan put it simply, and it has become one of the most repeated ideas in modern science communication. He said, "You are made of star stuff." It sounds beautiful. It is also quite literally a technical description of your biochemistry. Think about the scale for a moment. Our solar system formed about 4.6 billion years ago from a slowly collapsing cloud of gas and dust. But that cloud was not pure. It was seeded with the wreckage of stars that had already lived, burned, and exploded long before. Some of those elements had traveled across the galaxy for millions of years before they ever became part of the cloud that would form the Sun, the Earth, and eventually you, which means the atoms in your left hand might not share the exact same stellar origin as the atoms in your right. Different elements, forged in different dying stars, in different corners of the galaxy at different points in cosmic history, all eventually drifting together, collapsing into a single solar system, assembling into a single planet, and after billions of years of chemistry and evolution, arranging themselves into something that can sit here and read this sentence. Does that feel unsettling? It should, a little, because it means nothing about you is truly new. Every atom has already lived an entire cosmic lifetime before it became part of you. That iron atom in your blood may have spent billions of years as part of a star, then drifted through the emptiness of interstellar space for millions more, then became part of a planet, then part of the ocean, then part of a plant, then part of an animal, and now, briefly, part of you. When you are gone, it will move on to something else. It always does. Modern telescopes have let scientists watch this process happen in real time, in other galaxies, light years away. The Hubble Space Telescope has photographed the aftermath of supernovae, glowing shells of gas expanding outward, seeding the space around them with freshly forged elements. Even closer to home, the Crab Nebula, the remnant of a supernova recorded by astronomers in the year 1054, is still visible tonight if you know where to look. That explosion was witnessed by people on Earth who had no idea they were watching new elements get born. Here is the question worth sitting with. If every heavy element on Earth came from a dead star, then in some very real sense, you are a memorial. A living, breathing continuation of something that ended violently, billions of years ago, so that something else could begin. The gold in a wedding ring. The calcium in a hospital X-ray. The oxygen a newborn baby takes in for the first time. All of it traces back to the death of a star none of us will ever see, in a galaxy we will never visit, at a moment in time before Earth even existed. You were not created out of nothing. You were assembled, patiently, out of the wreckage of things that came before you. Every breath you take is a small, quiet echo of an explosion that happened before the Earth was even a fully formed planet. So look down at your hand again. It is not just skin and bone, it is not just biology. It is the end result of a supply chain that stretches back through supernovae, through the collapsing cores of dying stars, through billions of years of cosmic recycling. None of it was made on Earth. All of it was forged somewhere else, a long time ago, inside the furnace of a dying star. And somehow, against every possible odd, it ended up here, reading this, right now.